Hi there, Slooh. Welcome back again to yet another show. We've had two today. This is our second. So I hope you didn't miss us too much in between that 15-minute gap where we weren't on the air. But here we are again. This is where we're going to be covering the Jupiter Mutual Event, as the mutual events of Jupiter are sort of coming to an end this season. And we're going to be talking a little bit about what exactly that means. But sort of as a bit of a spoiler, we're going to be looking at two very cool moons of Jupiter out of the many that it has, and seeing as one potentially eclipses the other. And so to join me here for this show as we go through one of our a talk of one of our more intriguing planets in the solar system, I have with me once again Bob Berman, who was just around the corner at Icarus just a few minutes ago, and now we're coming over to Jupiter. So welcome back again. Thanks for being around
It's
so often for us, Bob. We appreciate it.
it's a pleasure, and this is a super pleasure because Jupiter is, you know, almost everybody's favorite planet to observe. Saturn may be more beautiful just as quick glance, but Jupiter is more intricate and, whoa, powerful, and I can't wait for this tonight.
It really, yeah. And so what we're going to be once again going live from the Canary Islands. It's one of Slooh's wonderful observatories. And so we're looking right now. The view behind us is the all-sky view from the Canary Islands. We see wisps with clouds here and there. But where exactly are we going to be focusing our telescopes in on tonight, Bob?
Well, it's just off to the right of this field of view. People who know the constellations a little bit might recognize most of the Big Dipper on the very top of the field, just a little bit to the right of center, but even going off the top of the field of view, and there's the arc of the Big Dipper's handle, arcing down to Arcturus. That's the brightest star in the field of view, big, slightly on the orange side of yellow blob. Now, going all the way right of that, you'd get to a star that's even brighter than that if only we could see it. But the all sky camera never points towards low in that direction. So, low in the west, that's where Jupiter will be. In fact, coming up, we're going to do a live show at Wanderlust and in Vermont this weekend for the solstice. And one of the things that will happen on Saturday night is a close meeting of the moon and Venus and Jupiter, and all that's happening right off to the right end of the constellation of Leo the Lion. Leo's on the right side of the field. So this is where it's happening.
It's really going to be an intriguing planet to see tonight. There's a lot of action happening, and we're actually, getting our first live images coming through from the telescope of Jupiter now, as we switched from Icarus to Jupiter. And this is actually, you were talking about it a bit, that it's far off on the side. Like, is that, does that cause any difficulties when it comes to imaging? Like, what should we be
Oh, well,
expecting?
it sure does, because we're reaching the end of our observing season. Jupiter's slipping into the sun's glare. It's just about as low as Venus is, and we know that Venus is usually a twilight object. So we loved it. It was a half-year long observing session that Slooh members enjoyed every minute of. Jupiter's the most intriguing, intricate, detailed planet. It spins quickly in under 10 hours. Its features keep changing, and so we love seeing it, but it's almost gone now for the season. So these are its final weeks, and so we have to catch it right before it sets, right before it slips too low, and that's what we're doing tonight.
And here we are coming in with our first live images of Jupiter from the Canary Islands. And so we see this fuzzy circular planet here that's coming in. And if you just look at it oh so faintly, you might be able to see the lines of Jupiter, and you can see the different bands that are going across the surface of the planet. And so you can see that definition there. But sometimes this planet looks a little bit better than it does at other times from the Canary Island scopes. Like, I would say that other times that I've seen this planet, it looks like it's clearer. It's more in focus than it does right now, and it seems like being maybe lower in the sky might be causing some trouble there.
You're being so diplomatic, Eric. This is almost garbage compared to the breathtaking, stunning views that we're used to through the great Canary Island telescopes here at Slooh. That's because Jupiter is so low, we're looking through lots of layers of atmosphere. And, that has to blur it. And so we're seeing the two main equatorial belts, um, but not the festoons and the curlicues and the red spot and the polar white storms and the dark storms and all of the detail that keeps our jaws hanging there most of the time when we use the Slooh telescopes on Jupiter. No, this is the end of the season. It's small. It's behind the sun. We're looking through lots of atmosphere, so we take what we can take,
And
and that's what we've
we're
got tonight.
actually sorry, Bob. I was just going to say that as it's coming into color, what we're seeing here live with these Slooh images is a live processing. So first we get the black and white, and then the color floods in. And so as we saw the color flood in, those bands across the surface of the planet, they're starting to look more significant. And of course, we have a lot of things we can do. This is T2 from Canary Islands. This is the second Canary Islands telescope, and what we're looking here is the high magnification view. And so it gives us more detail onto the surface of the planet, and we're struggling because of this, it being the end of the observing season. But we do have another trick up our sleeve here, which is we have a wide field view, which will show us some very different things. Which here it is coming up right here, and so we actually see some dots that are scattered across the screen. Here you see one here and here and here, and so there what we're looking at is the position of the moons surrounding Jupiter, which is what the important sort of facts that we're talking about today. Like, what are these moons doing here, Bob? They're scattered about quite a bit.
Oh yes, and it's almost no where to start with this, because these moons change the world. We call them the Galilean satellites simply because Galileo, in January of 1610, was the first person to observe them and to see that they go around Jupiter. Well, so what? So what if they go around Jupiter? Well, to him, it vindicated his belief in the Copernican um, sun-centered view of the universe, actually started by Aristarchus 1800 years earlier, which is that Earth is not the center of all motion, as many taught, and unfortunately Ptolemy and Aristotle believed, and the church taught at that time, but rather objects go around other things. And here was proof of it because these moons are going around Jupiter. In fact, they go around Eric like a marching band. Do you know that Io, Europa, and Ganymede each have orbits around Jupiter that are twice as long as the moon in front of it? In other words,
Huh.
little Io goes around in only one day, 18 hours. The next moon out, Europa, these are the two moons we're going to be looking at tonight, takes twice as long, 3 days, 13 hours. The next moon goes around Jupiter in twice as long as that, which is a week. So each moon precisely takes twice as long as the other one. And what I'm saying is that when Io makes 4 trips around Jupiter in that same period of time, Europa makes 2 and Ganymede makes 1. So they're like a marching band in perfect sync. We're seeing that tonight as one of them is about to go into the shadow of one of the others. So when you say mutual events, it means they can get in front of each other, behind each other, cast shadows on each other, and makes it easy because Jupiter is one of the few planets with no tilt. It's only tilted 3 degrees relative to its orbit around the sun. Mercury is the only other planet with less. It has 0 degrees of tilt, 1/20th of 1 degree. But it doesn't have any moons. And since almost all moons go around their parent planet's equator, and so do these moons of Jupiter, it means that without a tilt, we see them pretty much in a straight line. And that's why they can eclipse each other, occult each other, appear in front of or behind each other. And although the season is ending, we're going to see one last series of such events tonight as we keep watching.
And why do these series end? Does it have to do like that? There's a certain series for mutual events, and this was just we were right smack dab in the middle of it for a few months, and now it's ending. Like, why are there those different ebbs and flows of times when we can see sort of this interactivity between Jupiter and Jupiter's moons?
Yeah, because even though its tilt is only 3 degrees from the vertical, Jupiter's tilt itself, that's still something. And so, twice in our orbit around the sun will be oriented so that Jupiter's equator is just perfectly flat to us. And in other words, its north and its south pole are perfectly at the top and the bottom of Jupiter without one of those poles slightly aimed our way and the other pole slightly aimed the other way. And when you get the ring, the plane of the planet, the moon's going around it, it's almost like the ring plane of Saturn, perfectly edge on. That's when you can have these events, and that's what's happening tonight. So the orientation, the configuration is just perfect for it. It's too bad we don't have better clarity, but what can we get when we're looking through? Well, at that height, I'd say we're looking through 4 times more atmosphere than we do when Jupiter is higher up. So
And
it's Earth's atmosphere that's creating the lack of crisp detail right now because it's so low.
right, we're looking at it at the very limits of the horizon for Slooh's telescopes, and so I think it's a little bit up in the air, pun intended, right now as to how much we will be able to discern of this mutual event. But never fear, we have a lot of resources here in the Slooh Clubhouse. And one thing I'll be interested to see is maybe if somebody after the show could do anything to discern maybe a little better than we could live what might have been happening with Jupiter's moons at this point in time. And also, of course, we do have some incredible animations, some time lapses to show of what our Slooh members have done with mutual events throughout the mutual event season. And so we actually have a gorgeous look at the 3 shadow transit that came along just a couple months back. That was in the
Wow,
news for
wow! I
quite a
can't
bit.
wait to see that.
That's going to be a
But
lot of fun. But yeah, as we're nearing the time right about now when we should be experiencing this mutual event, so we can sort of see what we're going to see here. We have distinct looks at quite a couple moons here, and so maybe what might happen is we see one moon one moment and then it's gone the next. That would be sort of an eclipse of that moon, it falling into another
yes,
moon's shadow, and that's I
that's
think our hope for what might be happening in the next 10 minutes. And what are your thoughts on it, Bob? What do you think our chances are looking through at such an angle, the end of Jupiter observing season, the end of mutual events? Are we going to see it go out with a bang or maybe a foggy whisper?
No, I think we're going to see it. We've got Ganymede on the left. That's that moon standing by itself. And you've got Io and Europa on the right. Now, At the time that Jupiter is at opposition, that's when Earth is between Jupiter and the Sun. And all of these moons cast shadows straight back from our perspective. In other words, when they pass in front of Jupiter, the shadow is right behind the planet, the moon itself, onto the planet. Not now, because we're so many months past the lineup or the closest approach or the opposition of Jupiter. Instead, the shadows are all going from left to right and being cast by the sun, which is off to one side, and everything is coming at an angle instead of straight back. And that's why one of the moons can appear to go into the shadow of the other. And they're fascinating moons because Io is the one with all the volcanoes, typically 8 volcanoes at a time, actively erupting. There's no other place in the known universe that has such volcanic activity as Io. It's also screaming with deadly radiation because of Jupiter's super intense magnetosphere. Some of the material from Io, most notably sulfur, and there's sodium as well, that gets caught up in Jupiter's fierce magnetic field and producing more radiation than you get from being inside the core of a nuclear reactor where you don't want to be. So this is would be fatal to a human being in a matter of seconds. But the opposite is true on that other moon to its right, where you have Europa, which is the most likely place for life. And here, instead of being fatal to life, well, the radiation is high there also, but because of this thick ice, it might be a mile thick on the surface, floating on warm saltwater oceans, we think that the fact that it has an energy supply and it's salt water and it's been visited by comets containing all of the amino acids, which are the building blocks for proteins and life, we think that this is the most likely place for life outside of Earth in the entire universe. So one place is anti-life, and the other, and it's going to cast its shadow on the most pro-life moon in the known universe, Europa. Boy, do we want to go there and drill or burn our way through that ice to see what, if anything, is swimming or floating and existing in those oceans. I mean, if I had a bet, I'd bet that there's life there. So there's a lot more to these moons than little dots. These are worlds unto itself.
I mean, really well put. And these are worlds that, as we look deeper and deeper into what they are and what they consist of, and getting incredible views from all these spacecrafts going every which way about us in the solar system, we just it's something that can so easily spark the imagination and spark that spirit of discovery. And what are we going to discover? We discover new things every month about all of these intriguing objects in our solar system, and it's so much fun to be riding along with that journey. And I'm very excited to see we're just about at the point in time when the mutual event should be occurring. So the next image that we get updated into the system should be the time when we perhaps see the dot on the far right
It's an
disappear
eclipse.
courtesy
It's really an eclipse. And by the way,
dot left.
regarding exposures, it should be said that, we have a choice of how to expose these things. Now, to bring out the moons, which are fifth magnitude, that's so much fainter than Jupiter, which is magnitude -2. So you're talking about 200 times dimmer than Jupiter it is. So if you want to even see the moons at all, you have to overexpose Jupiter. So don't think that that bright, featureless disk of Jupiter that we're seeing is entirely due to the thick, miserable air that we're looking through. It's true, we do have a lot of, it's low in the sky, and therefore we are looking through a lot of blurry air, but that's not why it has no features. It's because we're deliberately overexposing its image to show the moons at all. In fact, I'd prefer if we even
Ooh.
made them a little brighter. There it is, went away, went into eclipse. And so we've got Europa in the shadow of Io. Should be mentioned that we got 4 moons, 2 of which are larger than planets, larger than the planet Mercury, and certainly larger than the demoted planet Pluto. Ganymede on the left there is a bigger object than planets are, whereas these 2 little guys are more like our own moon size. They're still substantial, but they're much smaller moons. So we now have one going into the shadow of the other. How cool is that? You can't get that here on Earth because we only have one moon. So the best we can do is have our moon, which tapers like a chopstick for its entire 250,000 mile length and just barely reaches Earth before that chopstick taper ends. In fact, when it's in the farthest half of its orbit, our moon has a elliptical orbit, not a round orbit around us. Uh, During those times when it's in the farther half, its moon can't even reach us at all. It can't. And so you can't get a total eclipse of the sun at all, the moon blocking out the sun. And so it just barely has a shadow that reaches us, but not the case here. We actually have one moon that can go into another, and that's because they're close enough um, to allow that to happen. It's nice to have backup moons, these four moons that are marching around Jupiter so dramatically, each one a different world, very, very totally unique places to visit. Some with craters, some with ice, some with radiation. Callisto, the farthest out, also a giant moon, almost 3,000 miles across. It is 3,000 miles across, has no radiation touching it. So that'll be a place to explore perhaps someday when our rocketry is a little bit more advanced than it is today.
There's so many places to go. Like it just really, you could put a bunch of papers in a hat and pick them out, and you would certainly pick out something interesting in our solar system, going out further and further and exploring. And I wanted to recommend here, Slooh members, if you maybe want to rewind the broadcast and you can see, and you can like flip back to now and back to a little earlier just to see the disappearance of the dot, because that's what it is. This is this mutual event that you've experienced now, this eclipse of moons so foreign from our own, and that is happening right before your eyes, happening right live. And
Beautiful. Can
that's
I make a request to? I know you've somewhere got in the archives some of our archived events of previous moons that Slooh members have taken, and our great Paul Cox, the master of the Slooh observatories, has taken showing these moons going around Jupiter and some of these other events. Because I haven't seen them in a while. It would be great to reminisce and watch previous events for a moment.
Oh, absolutely. I think, but in just potentially a couple minutes, we might get Jupiter, the moon re-emerging. I want to see if that's possible. But yes, we have right after the end of this mutual event, we have really some fascinating shots of what happens after you experience something live, what you can do in terms of image processing to really show Jupiter in its full glory. And so, if you were maybe a little bit dissatisfied with how Jupiter looked in the show, you stick around, please, because we are going to blow your minds. It's true. There's a beautiful image of the Great Red Spot just coming up, and so that should be happening very soon. But what we have here on the T2 telescope is we have what are called 5-minute missions, and so every 5 minutes is another progressive image that we take, and so just seeing sort of Jupiter at the very end of its observing cycle, we can see sort of if that's going to come out or not necessarily. But yeah, as we're seeing this mutual event in motion, any sort of thoughts you have, Bob, on the end of this mutual event cycle? It's really it's an intriguing, I think, three-dimensional experience. It really brings to mind how precariously fragile our view is and how easily it can change. You were talking about the tilt just earlier, and it's amazing.
Yeah, it's hard to think of the word fragile when you're talking about a planet so large that all the other planets could be combined and doubled, and you wouldn't have the mass of Jupiter alone, which is why some people describe our solar system as almost a two sun system. There is the big sun, and there is this one that some say is almost a star. Actually, even if it were 50 times more massive, nuclear fusion could not have broken out in the core of Jupiter. So it's not really almost a sun, but boy, two big objects here, Sun and Jupiter in the solar system, and the other planets are almost like achu, afterthoughts, almost don't even count. So big, massive object, but when you're saying fragile, the events are temporary. Jupiter spins so wildly that anything we see on one side, let's say the red spot, this giant hurricane like storm, will chug across while our Slooh members watch. And in only 5 hours, it'll go from one edge of Jupiter to the other while we're watching. So we actually see these changes. We see the moons go around. It's one of the most animated things that we observe. Here at Slooh, we look at galaxies that will not look any different 1,000 years from now. because they're so far away, and even though they're spinning and they do have their own life to them, or the Orion Nebula, which has its own life to it, those beautiful tendrils of gas are coming and going. They're being pulled in by gravity. New baby stars, blue stars are appearing like little robin eggs, little blue objects that appear before our eyes. But the time frame are thousands of years in which to see any possible changes at all. Not here. Here, we're talking about minutes to see the change from one view of Jupiter and another. So it's a fabulous object, very different from many of the things we observe here at Slooh. And yes, I'm a little sad to see our observing season end. But a few months from now, after it goes behind the sun and we start to see it reappear on the other side, there's always some maverick Slooh members who say, I got first dibs on Jupiter, and ask the Slooh telescopes to catch it when it first reappears as it slides over more towards Leo. Right now it's in Cancer, but it's moving steadily towards Leo, and we're going to see that as it reappears in the autumn.
It's really, a cycle of planetary life here. And as we were getting to the end of Jupiter's planetary cycle. It just went behind the horizon of our telescopes just now. And so what we can move into here is what you were talking about earlier. We have some great animations of Jupiter throughout this observing season. This is one just to give you a sample of the motion of the moons and the motion of Jupiter. This is not a mutual event, but just showing you, in particular, the Great Red Spot coming to us from observatory engineer and community manager Paul Cox did this incredible animation here that you'll see in just a moment.
Isn't that gorgeous? Notice how Jupiter goes from blurry to sharper, and that's, of course, the nature of live observing. Our own atmosphere sometimes has more turbulence depending upon how many cold and warm air layers are between us and outer space, and other times it steadies up and allows us to see more detail. And so, uh, even as we're looking at 5 minute intervals, we see the conditions changing. At the beginning, when you see it steady, in addition to the beautiful orange red spot, it's never really red. Uh, Although I have seen it brick red. More commonly, it's orange or even beige. But look for little blue spots too around its equator. You'll see distinct little blue areas, and those are places of blue sky. Those are the places where we can see through the atmosphere, see most deeply down through uh, the lowest levels of the atmosphere. On the other hand, the great red spot there is high up. It's floating 50 miles above the next nearest cloud. So it's in 3D. We're seeing multiple layers on Jupiter's surface through these great Slooh telescopes. And while Jupiter's spinning, in only 9 hours, 50 minutes at the equator, really fast compared to the 24 hours of Earth. Or, if you want to be technical, 23 hours, 56 minutes, and 4 seconds. While that's happening, look at those moons going around Jupiter while we watch. That's what we see here at Slooh. You can always tell them apart. Io is always going to be the most orange of the moons. Ganymede on the left is always the brightest of them. Callisto, no other moon can get as far from Jupiter as Callisto does. So they become friends. And you don't have to even look up which ones they are. You can tell which of the Jovian satellites you're seeing just by noticing some details through our Slooh telescopes here. It's so much fun.
Really is solar system in motion. And there's just, as you've been pointing out all these features. This is what we have when we don't even have mutual events, and then mutual events add this extra added dimension to it. Like, here's another this is a transit of Io across the surface of Jupiter, from Paul Cox as well. So you'll see this shadow encroaching upon this planet from our view. There it is, Io and its shadow, and that's going to move across the surface of Jupiter. And it's an amazing thing to see just how many variables are in this whole um, Jupiter equation here. There's so much going on.
Yeah, including the variable nature of the incoming sunlight. Like, watch Io when it's passing in front of Jupiter, right there. Notice the shadow is almost directly behind it. And as it parades across or just above the cloud tops of Jupiter, the shadow always stays right near it in this view. And this tells us that this particular event happened very nearly at the time of Jupiter's opposition. When Jupiter is closest to Earth, that always happens 1 week a year. And that's when Earth is between Jupiter and the Sun. And so, from our perspective, all those moons cast shadows straight back from our perspective. Look at that. See Io's shadow going directly back from it. You don't see that tonight. Right now, we saw Io casting its shadow way off to the right and hitting Europa, which was some distance from it. So that's another variable factor, the lighting. And you can see a difference even over the matter of a few days. We see the changing directions of the light. Also, notice that around the edge of Jupiter, right along the limb, in other words, the edge of it, Jupiter's a little darker.
Mm.
In fact, quite a bit darker than it is at the center of Jupiter. And that's because, again, the sunlight shining straight down on Jupiter and most intensely illuminating the part near the center of the planet from our perspective. Whereas the edge of the planet, that's where the sun is lowest in the sky. And so, of course, the light is less intense. And there are many subtle features like that. Festoon storms, the white storms that we see on Jupiter through these great Slooh images, the little white storms have a lot of lightning. Some of them elliptical, some of them are closer to round on the clouds of Jupiter. The dark storms, usually smaller, are more transient. They don't last very long. The polar regions on the top and the bottom, see they're a little darker than the rest, and you can see the red spot just sweeping across the planet in less than 5 hours. So, boy, there's always lots to see on this wonderful planet.
Oh, really? Yeah, and each shadow adds some a further dimension, further activity. This is perhaps what some of you have been waiting for, the triple shadow transit animation, courtesy of our wonderful Slooh member Sebastian. I believe this was his first attempt at animations, and this is great to see this coming to life here. So we see one shadow, two shadow, three shadow uh, coming up right on the side there.
And notice the different speeds in which the shadows are parading across because the moons themselves, obviously, a moon farther away like Callisto, is in a slower motion than rapidly moving Io. I mentioned earlier that Io whisks around Jupiter in just 1 day and 13 hours. Imagine that. Our moon, it's about the same distance from Jupiter as our moon is from us, but our moon takes a month. 27 and a third days, 27.32166 days, want to be exact. 27 days to go around our planet Earth. And here's a satellite at the same distance, our moon is from us, from Jupiter, and it goes around in only 1 day and 18 hours. That shows how Jupiter's supergravity, its gravity is 318 times stronger than ours. And so it's whipping around this little moon. But the farther away moons, like Ganymede and Callisto, they're more leisurely. And we're watching this happening. We're watching the shadows cast by the moons doing what the moons are doing and moving at different speeds. And while that's happening, there's Jupiter itself turning wildly. So, motion within motion. You never run out of things to see when it comes to Jupiter. The more you see, the more you want to see.
Really, I mean, well put again. And there's just this is just a little bit of a small insight into what Slooh members have been doing with these mutual events over this past season, and it's been quite amazing to see what they've done with it. And really, if you want to see more exciting stuff about Jupiter and what Slooh members are doing with it when it's up, uh, here welcome to a little preview in the clubhouse of the Jupiter Watch group that is here. And so you can see there's moon phenomena, mutual events. Like if we just go to the mutual events section of the Jupiter Watch group, it shows you all the different timings that you could have looked at. And there's great image galleries of just what people have contributed so far. Like if we look at the latest sort of time lapses from this year, you can see all sorts of different Jupiter events here coming in. Here's another animation of the triple shadow and two moon transit. If you just want to go in there in the clubhouse and check that out, there's so many images that our Slooh members have contributed because it really, as Bob's been talking about it, it's really been bringing it home how much there is to explore on this planet. And I think our Slooh members really do take a lot of advantage of that. I hope that if Jupiter is a passion for you, you won't stop exploring it, because really, I don't think there's a place you could stop where you have learned it all. There's always going to be more. And so, as we've been, we're heading off into sort of the sunset of this Jupiter observing session and this Jupiter show. Any sort of last thoughts on this really incredibly dynamic planetary system and beautiful planet to observe?
Well, last thoughts, I'd say no, they're never last thoughts because
Mm.
I'd come back to it over and over again if it weren't for hogging up the telescope. And, I'd come back to Jupiter every night if I could. So, yeah, sorry to see it sinking into the sunset. I want to remind everybody that if you're in a place where it's clear for you this Saturday, any part of the world, that you can get that western view, let's say around 9, 9:30, 10 o'clock, definitely check out the post sunset sky because there will be Jupiter and Venus and the moon forming a gorgeous triangle, arguably the best conjunction of the year. So look for that, and that might really be the swan song of Jupiter. No, it won't be. I happen to remember that on June 30th, last day of this month, it's going to come very, very close to Venus and be striking in that same direction, west after sunset. So it's still got a little ways to go. I mean, it's getting too low to give us decent telescope views, but it's still not quite finished dazzling us before it vanishes behind the sun.
So yeah, I think the moral of the story is, just keep on staying tuned. There's going to be more Jupiter coming up, before you know it. As it sinks down, it's just going to count down the days till when it comes back up. There's a lot more to look forward to, and of course, we are never ending our Slooh shows, and so this is perhaps the end for today. But coming up this weekend, we're really going to be going all out to celebrate the solstice and really the what it tends to mean in terms of the division of the hemispheres, and what we see as winter in one place and summer in the other, and sharing with you a festival, a celebration of light. As Bob Berman is going to be joining Ali Grimes at Wanderlust, and they're going to be showing some incredible night views to the people that are going to Wanderlust as well. And we'll be talking a little bit about how that went as well. I hope that trip is going to go great for you, Bob, by the way. That is, just another
Thank
fun
you.
way to explore the universe, going to Wanderlust and then sharing solar views on the solstice with our Slooh members and beyond. It's going to be a great time. And I hope you have a great time at Wanderlust.
Thanks, Eric. Thank you.
And thank you, Slooh members, for joining us on this journey. If you saw the Icarus show, that's great too. You got a double feature today, and we'll of course be having more and more as time goes on. So please do let us know what you enjoyed and what you didn't, because we'd love to have you as a part of this conversation. And so thank you again for joining us for this show, and we will be seeing you so very soon. But for now, this has been Eric and Bob for Slooh. We'll see you again.